Welcome to Signal System lecture series. In this lecture, we study about amplitude scaling and amplitude transformation. So amplitude scaling, so there is basically transformation applied to time axis can also be applied to the dependent variable, that is amplitude scaling. So amplitude scaling means amplitude we can shift, and amplitude can be increase, can be down. So amplitude scaling maps the input xt and yt equal to a into x of t. Here we just multiply the signal into some constant that is known as amplitude. So, and this one a is real number, real signal. So geometrically, if we are discussing about amplitude scaling, we are having one example here. Xt is the sine wave. That is the amplitude one in positive and negative one in negative. If we multiply this signal into 2, just multiply this signal into 2, the amplitude also multiply with all time of signal by 2. So here we got that the signal height is 2 in positive and in negative same. If we divide the signal, if we divide or if we multiply the signal by 1 by 2, the signal, original signal also multiply by 1 by 2. The signal, that the original, that was the 1 in positive and in negative in also 1. So in 1 by 2 into xt, the new signal also having 1 by 2 means 0.5 into xt. The height is, new height is 0.5 in positive and new height in negative. Similar, if we multiply the signal minus 2, so the height is reverse, means the height is also reverse and multiply with 2. The signal is reverse and multiply with 2. This is known as amplitude scaling. Now amplitude shifting, we just find that the shifting property for the continuous and discrete time signal simply by mean shifting across the time signal, across the time axis. Yt equal to xt plus b. If we apply yt equal to x plus b, here b is the real signal, so geometry amplitude shifted added the vertical displacement to the x. Here, if having the signal of xt in this example, if we add b, so the signal is shifting around the y-axis, vertical axis, according to applied value of b. So if we combine the both of things, combination of amplitude and scaling and amplitude shifting, we just found that the new signal transformation, and that is known as amplitude transformation. So the combination of the two, amplitude scaling and amplitude shifting, is known as amplitude transformation. We performed on the two operation for the transformation. The first amplitude scaling x by a, and then amplitude is shifting resulting the signal by b, and first amplitude is shifting by b by a, and then the amplitude is scaling the resulting signal by a. This is known as the amplitude transformation. Next one, we are discussing about the, now we are discussing about some other property like right-sided signal. A signal x is said to be right-sided if some real constant of t0, the following condition of xt should be true. Xt equal to 0 for all t less than t0, that is known as right-sided signal. So if we are taking some example here, at t equal to t0, the signal should be right-sided. Here we are measuring around the t0. at the point of t0, in the left hand side the signal should be 0, and in the right hand side the signal having some values, that is known as signal is right hand sided. If we shift it to t0 into origin, means t0 equal to 0, that means the signal is said to be causal system, means xt equal to 0 for all values of t less than 0, means at the left hand side of the signal origin, the signal having no any values, the signal values is 0, that is known as causal system. So we can say a causal signal is a special case of right hand side signal. Next one is left hand side. Similar, if the left hand side a signal is said to be left hand side if some real constant t0, the following condition holds: xt equal to 0 for all t greater than t0, means in this example the value of t0, value of xt is 1 at the time period of less than t less than equal to t0, and t greater than to t0 the xt should be 0. This signal is known as left hand side signal. If the t0 is shifted to origin, that is the signal is known as anti-causal, that means xt is equal to 0 for all value of t less than 0. This is known as anti-causal signal. Next one is finite duration and two-sided signal. If we are having the limited time duration, finite duration, that is known as finite duration signal. A signal is both left hand side and right hand side, it should be finite duration. An example is there, we are having the signal, some part of the signal in left hand side, some part of the signal in right hand side. So the signal xt having two-sided or two-sided signal, both sided signal, that is known as two-sided signal. A signal that is neither left hand side nor right hand side is not a two-sided signal. So we can another example like this. Now bounded signal is signal xt said to be bounded if there is exists some positive real constant a such that xt modulus of xt is less than equal to a for all time t. This is an example of the bounded signal includes the sine and cosine functions. An example of unbounded signal includes the tan function and any non-constant polynomial function. These are the unbounded signal. The main thing is bounded signal means that having the finite value with a finite time period. Now next is signal energy and power. The signal energy contains equal to minus infinite to infinite integration xt modulus of xt square dt. This is known as the energy signal, and average power p contains in the signal xt is given by p equal to limit t tends to infinite 1 by t integration minus t by 2 to t by t xt modulus of xt square dt. A signal with finite average power is said to be power signal.